All right, trig, inverse trig functions. The derivative of inverse sine is 1 over square root of 1 minus x squared, right? And if it was inverse sine of a blob, what would you do?
Then you take the derivative of the blob on top.
Then you would have u prime over square root of 1 minus u squared, right? Inverse tangent, if it was derivative with respect to x of an inverse tangent of u. So, the integral of dx over square root of 1 minus x squared is the inverse sine of x. Now, there's a little addition if it's not a plain x. This could be something also other than 1. So, if we have a number squared there, then the integral of du or u prime over square root of a squared minus u squared would be the inverse sine of u over a plus c. But for tangent, it's a little different. The inverse tangent of du, or u prime, right, over a squared plus u squared would be 1 over a arctangent of u over a. So, formulas are already written. We also have the arcsecant. What is the derivative with respect to x of the arcsecant of u? U prime over absolute value of u. And instead of 1 minus u squared, it's u squared minus 1, right? So the integral of du over absolute, just u square root of u squared minus a squared would be still 1 over a, right? Yeah. 1 over a arcsecant of u over a plus c. I think it's an absolute value, isn't it? Yeah. All right, so quickly running through these, this is just straight arc sine, right, of plane x. This one is almost the same, only we have an a value. If a squared is 4, what's a? 2. And our u is plain old x, so, you know, no need for an extra step. But arc sine does not have 1 over a. It's u over a. Arc sine u over a. This one, classic arc what? Arc tangent. What's our a?
4.
What's our u?
X.
So du is complete. 1/4 arc tangent of u over 4, right? Plus c. I'm flying through these miles because I forgot to record. A is 3 because a cubed is 9. What's our u here?
2x.
So du is
2dx.
2dx. So we need a 2 and a 1/2.
So why do we just ignore the 4 in front of the 4x squared?
Answered twice already. The 4 is 2x squared, so the 4 is taken care of. U over a. This one is classic arc tangent with the 4 taken out, right? Arc tangent of x. This one's also tangent, arc tangent, isn't it? What's our u? What's our a? 1. What's our u? 2x. Again, the 4 is being taken care of, isn't it?
Maybe.
Du is 2dx, which we already have. Check it off. So we're looking at 1 over a, arctangent u over a. But this one is a definite integral. Guys, all of these, if it's free response, you understand this is part of your answer. This will be part of the points on the AP. That, in fact, that antiderivative, if this is maybe a 3-point problem, the antiderivative would be one of the points. Sometimes the setup is a point, depending on what the problem is. And then the antiderivative is the second point. And then the answer is just one of the points, right? So plug in the top one. 2 times a half is 1. Plug in the bottom. Free response. But we've already said the angle that has a tangent of 1 over 1 is 45 degrees, pi over 4. And the angle that has a tangent of 0 is. So, have we made it to this one yet?
Yeah.
If we look at this as an arc sine, we notice there's an extra x because the u is just going to be 2x. So du is just 2dx. So this one we have to rewrite and just think of it. We've already done problems just like this. Change it to a blob to the negative 1/2 power. Now, what do we have to manufacture? A negative 8 to have the derivative of the blob complete. Check it off. What do we do now?
Power up.
Power up and divide by the new power, which is what I forgot. Dividing by 1/2 is multiplying by 2 over 1. Negative 1/4 square root of 9 minus. If I were doing this on a multiple choice, they would probably go back to square roots just because it started out in square roots. Now, number 8. This is one we've not made it to yet.
Isn't the bottom is the top square? No.
No, x plus 2 quantity squared is x squared plus 2x, plus 4x plus 4. So it's not just, you can't cancel.
Isn't it, I could be wrong, but isn't it u prime but with an extra 2?
It is u prime with an extra 2, kind of, yes. But I know this is a new skill that we haven't really talked about. But if I keep that denominator the same, is this a legal maneuver?
Yes.
Does everybody agree? Essentially, that's just saying that's 2 fractions with a common denominator. If there were three terms on the top, I could split it up into 3 fractions, correct? As long as I keep that whole denominator together. So, what is this first question?
No.
Okay. What is this first one reminding you of almost?
ln.
Yeah, in other words, the
U prime over
u prime over u is almost complete. What do we need?
So 1/2.
And you're factoring.
We got u prime over u classic,
1/2
ln.
x squared plus 4.
and I don't need the absolute value because it's already going to be positive, right? On this one, our a squared is 4, so a is 2. U is just plain old x, so du, that 2 can just come to the outside, right? And we're looking for arctangent, but that'd be 2 divided by 2, which is just 1. Arctangent of u over a, right? I brought out the 2, but then I had to multiply it by 1 over 2, right? So they canceled out.
They should have made this a definite integral. It'd be so much fun to do.
I mean, there'd be a lot of ln's in your answer.
Go for it, dude.
Excuse me.
Bless you.
So, guys, that is when you see, the homework is not on the back.
Yeah, homework's on the back.
I got a couple more to add to our back though.
Oh, no.
Let's stretch ourselves.
If we're stretching ourselves, we don't need homework. None. I will.
Mm.
Oh, I think I know what we're gonna have to do. I think we're gonna have to substitute the bottom first, so it's not split that.
1 minus cosine sine squared would have been cosine squared.
Wouldn't you put a 2 in front? No, okay.
Think of the new stuff we've just been looking at.
Oh,
A is, oh, it's just an arctan.
It is an arc tangent. If u is this thing, right, sine of x, a function of x, u squared is sine squared, right? So u is sine of x. So what's du?
cosine?
Cosine of x dx. Check it off. It's there.
Check it out.
And the a is just a 1, right? So 1 over a, arc tangent of u over a. The u is sine of x, right?
Well, this is simple. Wait a second. Oh, okay, never mind.
Right? We just said the arc tangent of u. What are we doing next,
Plugging in pi over 2.
Martin? Who's distracted by something? I'm not sure what. What are we doing? Plugging in what first? For the x, what is the sine of pi over 2?
You're 1.
It's 1.
I didn't almost say 0.
And the sine of 0 is 0. We've just is pi over 4. We are at this point we already did that problem, right?
So if you have arctan, you can just treat it like normal tan?
No.
No, it's
No,
what
it's
angle
the
gives you.
angle.
Oh, it's the angle.
The angle that gives you the tangent of 1 over 1.
Not forgetting his trig. Gosh, stop swearing at people in sign language.
Ooh, here's a really good one.
What does this even mean? No, isn't it like the Star Trek thing?
Live long and prosper.
Oh,
Star Trek.
I thought it was just bragging that you could do that. You know, some people can't do
God, you're one of
Oh,
those
you
filthy
backed it off.
Trekkies, aren't you?
Can you do the thing where it's like really fast? Or, sorry.
I was thinking that this one was going to be a split up and we would have a minus with an arc tangent. But
But
The top is just x squared minus 1 x squared.
the top is just x squared plus 1, x squared minus 1, right?
so then you cancel.
So would that just go to x cubed over 3 minus x plus c?
Yep.
I'm just not sure I fully can grasp that. If I split this up, x squared plus 1 into x to the 4th is what?
X squared. And then
X to the 4th plus x squared. Subtract.
the remainder of the
So minus 1.
What is
That's long
happening?
division.
That's long division. Oh, there it is.
Yeah.
Here's what happens. When I long divided it, I got that x squared minus 1 plus 1 over x squared plus 1. and I've got a plus and a minus of the same thing. So they would cancel. I've proven it to myself.
Oh, you proved it.
I was proving it.
Hurts my brain. I can't.
Long division is
I like long division.
Not
We've just been doing it in
Division.
pre-calc, so I'm pretty, fast with it.
I actually,
It's
I
definitely
like
not, it's not as bad as having to figure out which is zero, so.
I have a girl at
I like
Northside that
this.
swears by long division. She's like, I just would never choose synthetic, Miss Washington, ever.
I love synthetic.
no, that is pretty
You
easy.
just
I
find
don't
the
remember how
zeros,
to
and
do
like that's
either
the
right
only
now.
one. I
Yeah.
love synthetic.
All right, so let's get some homework.
Miss Washington, I'm
Hey.
gonna be completely honest. I can't do long division or synthetic right now. I forgot.
I prefer
Well-
one division, the normal, like the multiplication, where it's like 356 times like 213. I don't really do that.
Also, I completely forgot how to hand multiply.
Yes, I'm assigning 3 challenge problems here.
No.
And so I want you to look at a couple of, a little bit heftier. Hefty.
What the? That's what my trash bags are.
I was gonna say that.
All right,
We are hefty. Bumper.
oh, this has some legit, interesting, work with it. What does this part look like? It's almost U prime over U.
Oh, so you just split it.
But I need a plus 2, right? So here's what I can do. I can add 2, and then I can subtract 2.
What?
Does this make sense? All of that is in the numerator, right? So then what I can do is just split it up into 2 fractions.
That's foul.
So first part, and even do it as, dx. Everybody follow what I've just done?
Yes.
I took the numerator, I added 2, and I subtracted 2. So this first one is classic U prime over U, agreed? No problem there. The next one is not so classic. Are you at a loss for the thought?
Couldn't we just?
So what if you take the negative 7 out?
Yeah, what?
You can take the negative 7 out. But, guys, complete the square.
Oh, bro.
Half of 2 is 1.
Squared.
So add 1, subtract 1. Here's what I'm seeing. Dx over x plus 1 quantity what? Squared plus 1. Now, are you recognizing the form?
This is icky and gross.
Why is there just a random
Stinky.
+1 there?
Because you're wrong in the square.
Because
I had to have it to complete the square, yeah.
Because x squared
No,
or x
guys,
plus 1.
Recognize the form.
Okay.
Arctan. There's your u squared. U is a function of x, right? A is just 1. What's du?
2x.
No. U is just what's inside there, right? What's du? dx. Check it off.
Wait, what happens to the -1 then?
It becomes a plus one.
2
minus
minus 1 is positive 1.
Becomes a
Gosh, why?
I don't like that.
You don't like music back?
You want
Bro,
So
it's not
guys,
supposed to be
this is an arctangent of u over a.
Maybe the whole engineering thing is just nothing to do.
That's what I'm saying.
These are your challenge problems, without a doubt.
That's definitely a
How
Um,
the easy ones then? If this is the challenge.
What about something like this? Just one more challenge example. I'm only giving you 3 of them, so,
Wait.
or there's a couple more mixed in there.
Included in
I don't want to.
Yeah, they're already included.
Doing?
This would be a good practice for how.
Dude, you just made it snow on my shoe.
Ew.
What? Why'd you, ew.
He was shaking out his dandruff.
That's what I thought.
Ew.
It's the paper.
Alright, hush, please.
Ooh.
So, if I tried to make it a blob to a negative 1/2 power, I would need a negative 2x plus a 4.
So you don't have an X.
I don't have an x. What other new type has a square root on the bottom?
Sign.
Arc sine. So what's the arc sine formula? Is it a squared minus u squared?
Yes.
Is just arc sine of u over a, right? Alright, so the u, which is the blob, the function of x, is after a minus sign. Are we good so far because there's a minus sign in front of the x?
Yes.
Yes. So here's what we're going to do. Take out that 2. Keep the square root. And I'm going to bring a negative over here, factor it out, leave a space, and I'm probably going to have to add something over here, correct?
Yeah.
Complete the square. What is it?
Negative 4 divided by 2, negative 2 squared is 4.
We're going to add 4. But are we really adding 4?
No, you're subtracting.
We're really subtracting 4 because a negative had been factored out.
Yeah, yeah.
So add a 4 there. Everybody ready to rewrite one more time? 4 minus what? What's the u?
X squared minus 4x plus 4.
Which is written as x minus 2 quantity squared, isn't it? That's why we completed the square, so we could say x minus 2 quantity squared. So, our u is just x minus 2, isn't it? What's du then? D 1, right? And the a is 2, right? From there. No 1 over a, just leave it. Arc sine of u over a. So it looks daunting, but
Yeah.
break it down, complete a couple squares. I've got 3 problems that are challenges. So. And everybody got page 368, 1 to 45.